Okay, looks like we're good to go. Okay, welcome to Orange, New South Wales. Welcome to SWEDGE meeting here in Orange. So SWEDGE is the Central West Exploration Discussion Group, if you're wondering. And we're here today for a technical meeting with the support of SGS. So thanks very much to SGS for making this happen tonight. Jeff McLean, who's the local SGS person here, is unable to join us because he's unwell, but he's been instrumental in making it happen tonight. Thanks also to Jessica for having this broadcast online. So welcome to all those people online as well that are here. So, and also to John Woods, our presenter tonight from SGS. I'll move to the first. A reminder that the Discoveries in the Tasmanide Mines and Wines Conference is on later this year. So early September in Albury. Registration is now open. So I recommend getting to that because it definitely is the best conference for mineral exploration and discoveries in Eastern Australia. I'll now hand over to Mark Arundel, who will talk about some other training opportunities coming up this year, and also to introduce John Woods. Thank you.
Thanks, Barton. I'll just mention on the Discoveries in the Tasmanides, the field trip will be from Melbourne. Thank you. From Melbourne, and we'll be looking at gold deposits in Victoria. There's also a series of workshops as well. And what I'm talking about here is a series of online workshops and one face-to-face. I don't know whether people here are familiar with Richard Lilly, but he's done a phenomenal job of getting 9 workshops organised over the next couple of months, going from porphyry systems through ore textures, breccias, an introduction to exploration for people who may well be non-geologists, looking at gossans. There's one face-to-face where they're actually going to be doing work on QGIS, and SCAN workshop, one on exploration, geochemistry, and Lee Rankin doing a 2-day online workshop on air mag interpretation, and finally the 9th one that he's organised is on tin systems. And if you're interested in those, please get in contact with Richard. The only one I've actually got any details on is the one that I'm actually doing with Richard myself, which is the exploration one, which full registration is $600 for 2 days, AIG members of $400 and students of $60. So, may I please now, or should I say it's my pleasure to introduce John Woods, who will be speaking to us today from SGS. John is the new technology manager for SGS, and that's a global role within the company. He's a geologist and a chemist and has over 30 years working within industry, primarily within the mineral sector, but he's also done some work, dare I say, with the oil and gas sector as well. However, he's identified a number of new technologies for laboratory and field applications, including the use of portable X-ray and infrared based systems. Using artificial intelligence and data analytics to produce quantitative methodologies, John has been able to apply these systems for interpretive strategies in both process control and resource assessments globally. Operational successes have included the application of FTIR, Fourier Transform Infra-Red Spectroscopy systems in the quantification of minerals and critical elements. So please, could you join me in welcoming John to the front? Thank you.
Thank you very much for the introduction, and thank you for inviting me here today to speak to you about some of the technologies that we are developing at SGS, and also some pre-existing technology which it would be good to remind you about for exploration. So 2 main topics today I'm going to talk about. One is MMI, mobile metal ions, which is used in the exploration stages for identifying targets. And then I'm going to talk about the fast technologies, which are some of the new cutting-edge technologies that we can use for a variety of different applications. applications including elemental and mineralogical analysis that are very rapid, can be used on site, and also fit in with green strategies in that they don't require things like gas supplies or high energy contents. So tell you a little bit about SGS first of all. We are a global organisation with over 2,000 officers and in the order of 100,000 employees. And we have a number of laboratories here in Australia, including the development of a lab here in Orange, as well as our main laboratories being in Perth and Townsville. So, first of all, I'll talk about the mobile metal ions. So this is a technology which has been around for about sort of 10, 15 years, and it's a way of identifying targets without the need for a straight-off drilling program. It uses the fact that you have ions which are bound to particles, and they move through the column, through the geological column, to the surface, where you can take samples and analyse them and identify hotspots. So it's a specialised leaching technology. So you have a mineralised deposit at depth, and you're wanting to identify it, ideally through soil analysis at the surface. So what we do is we take samples from just below the organics layer, so a consistent depth, with one of our special kits, which is all plastic based, so there's no metals content to that. We carry out a special leaching process and identify a very wide range of elements. And that we can then take that data and produce a heat map to very successfully identify not only where your deposit is at depth, but also the type of deposit and mineralisation that we're looking at. So it works on the principle that you have elements bound to the surfaces of particles, soil particles, and as you have water flowing through the system as we have at depth, these elements dissociate, move up through the column, and then we have a specialised process for identifying and quantifying them. So we're looking really at bound elements. Works particularly well for those sorts associated with VMS deposits, but we've also applied it in gold and even recently in lithium with a high degree of success. So bound metal ions, we can analyse them at very low levels, so we can identify even very relatively low levels of mineralisation. And we have two different suites. We have a standard high-level suite which analyses the sort of the main VMS type deposits, and a low-level suite for identifying gold. So we're looking at the unbound metal ions moving from the source up through layers for identifying direct mineralisation by hotspot analysis. So we've also been looking at some new extracts now with MMI. These will allow us to more effectively extract the precious metals. So originally MMI was largely based around your sort of standard base metal type analysis, but we're now able to identify gold deposits very effectively, and also we've also now moved into the lithium sector as well. So the MMI analysis, the basic suites, consists of a wide range of elements, including some of the rare earths. And the MMI Plus, we're now able to identify very low levels of detection, including for elements like chromium and vanadium. The advantage of MMI is that it picks up the most subtle of features that you would probably struggle to identify if you were doing standard sort of geomagnetic surveys, or any of the more sort of standard approaches, standard soils analysis, for example, By aqua-reader digest, you're going to get so much of the other elements effectively clouding the issue of what you've actually got as mobile. And the beauty of this is it's a specialised digest which is only identifying those mobile ions, and in only identifying those mobile ions, you are clearly identifying what's going on at depth. So the limits of detection compared to a soils analysis are very, very low. In fact, we're usually talking 1 to 2 orders of magnitude lower. So 1 to 2 orders of magnitude improvement in the sensitivity in identifying in-depth materials. So if you pick stuff up at very low levels, you get very clear indicators. There's none of this, trying to identify something that may be something at, say, 5 ppm, something at 10 ppm. We have significant peaks which we are clearly able to identify. And it gives you a clear hotspot identification. Sampling itself is very, very simple to do. You simply dig below the organic layer, so typically greater than half a metre in depth. Take a sample using our specialised samples kit and send the samples through to ourselves for the analysis, and then we can interpret the software with software systems, shall I say, or you can interpret it yourself to identify those hotspots. The field sampling procedures are quite simple. You're only looking at 200 to 300 grams of material. We're not talking about having to take drill deposits. And we get very sharp anomalies. They are seen directly above or on the up dip of mineralization. We can identify commodity element responses. We have very few issues with anomalies. That's particularly because we have this specialised leaching process, so we don't have the issue of, with the standard soils analysis, of, as I say, very little difference between the elemental contents, clear peaks. And we can also identify even over weathered or transported systems. And the data is reproducible over time. So here's an example showing some of the hotspot anomalies. We've also got a new MMI developed system, and I'm afraid it has the rather interesting title of DOCS. So it's degree of geochemical similarity. So it's effectively, if you've done any work, sedimentary rocks, it's what I would call provenance testing. So you're identifying large-scale geological features with similar elemental contents or similar properties. So this allows you to identify regions of interest which may not have already been identified. So where you might want to look at going for gold analysis next, or lithium, or whatever the element of interest may be, by understanding those geological structures, which can come out of this type of analysis, you can look at where you might want to go. Okay, next part of the talk, I'm going to talk about our FAST technologies. Now, these are some of the new technologies that SGS has been rolling out globally. These technologies allow us to do analysis in field. So you can actually have analysis next to your drill rig, or you can have a mobile sample preparation unit, which is a mobile unit allowing you to prepare samples and analyse in field, or you can send the samples back to our main laboratories. The advantages of this technology is that it is, as the name suggests, very fast. We're talking about dealing with hundreds of samples a day. So, as you can imagine, that allows you to make decisions on where you're drilling there and then. So the FAST technologies that I'm going to discuss and that I've been developing with SGS and the SGS teams are Fourier Transform Infra-Red Spectroscopy, which is a bit of a mouthful, I know, but it's a great bit of technology, originally from the pharmaceutical sector of all things, where it was used for identifying drugs and also for what we call mineral excipients. So that's the minerals, when you have the pills from the pharmacy, most of that pill is actually a mineral. Gypsum is quite popular, and only a small amount is the drug. So a lot of the pharmaceutical companies not only need to identify that you've got the drug present, but they also need to understand what mineral it's based in. So the principle that you could identify minerals using Fourier Transform Infra-Red Spectroscopy was there, and that's now been brought forward to be able to provide semi-quantitative, and indeed in some cases fully quantitative mineralogical analysis. And Fourier Transform Infra-Red Spectroscopy works on how bonds wobble. So it's very good for minerals which have, I suppose, we call wobbly bond structures. So things like your clay minerals, your alteration minerals. So the things that XRD struggles with. It's also very good at dealing with minerals which have orientation effect issues. So your micaceous minerals, where orientated one way, get one result, orientated another way, get a different result in an XRD because of the way the XRD works. So good mica contents, good clay mineral contents, but it's also very good for most of the other main minerals you're going to be interested in, say your quartz contents, your feldspars. You can use it statistically also to look at where things like gold is present or not present by looking at the relationship between mineralogy and gold contents. It can be used in some cases for elemental analysis where you have an element with a very specific bond type. So we have done some work which is still being finalised in the lithium sector, where you can get things like lithium contents in spodumene using Fourier Transform Infra-Red. In the bauxite sector, it's already utilised very successfully for identifying elemental contents, namely your total alumina and your total silica, but because it's also looking at the other sort of mineralogical lead properties, you can also get things like available alumina and reactive silica, as well as the organic content, the oxalate content, which is another key point for the bauxite market. For iron ore, it's very good for identifying the key iron ore minerals. So when you're looking at, for example, milling properties, hardness properties, and this also applies for any ore type that you are grinding up, because you can do a very quick and effective analysis of those mineral contents, including those very soft minerals, which you would struggle with by other technologies, and you can start to look at things like brittleness indices, hardness indices, and the effects with NET's properties on flotation cells, and also viscosity as well. So we've got, and this is something that we've done, for example, in the gold sector, and also in the tin sector, where there's key aspects for processing, and I would say I'm not a NETS guy, so I won't claim to be an expert in that, but we've been able to use the AI-based predictive modelling to work out those key NETS properties using the FTIR. Okay, the other technologies we've been doing a lot more work with is portable XRF. Many of you may already be familiar with portable XRF for elemental analysis, but we've been doing much more advanced modelling with the pXRF so that we can detect a wider range of elements to much lower levels. And we've also been using, again, this elemental data to predict properties, etc. In combination with the pXRF, we've also been working with a company called DetectORE, which allows us to do gold assays. We're talking about gold assays down to somewhere in the order of 5 ppb. So it's a specialised extractive technique, and that extractive technique effectively concentrates the gold, and then you can analyse all the gold with a pXRF. You can also use that pXRF to do your standard pXRF analysis at the same time, so you get effectively 2 for the price of 1. Other technologies we've been working with are PNIR. This is a kind of more simplified version of the infrared analysis, and that's really for looking at rapid, semi-quantitative determination of mineralogy, but we have predictive AI-based technologies now, which allow us to give relative concentrations of a much wider range of minerals, huge range of minerals, certainly enough to look at the complexities of alteration halos and skarn deposits. We have the hyperspectral and EDX core scanning technologies, which obviously you can get detailed core analysis, so you can get a detailed mineralogical log, take high-resolution images, and you can also combine it with XRF technology to give you elemental contents as well. With some of the high-resolution imaging, you can also start to look at things like crystal structures or grain structures, depending on the sort of material that you're looking at. And finally, we're doing, which sort of is touched on in all of these, a lot more with data modeling. So we do a lot more with artificial intelligence-based data modeling, partial least squared mathematical modeling, and eigenvector plots as well for looking at relationships between minerals and things like gold and other metals. So these technologies have different applications depending on the project requirements, and the stage of development of the technology packages are developed to reflect these varying needs. So what we can do is we can look at what you need, and we can effectively provide you with a package of technology which will provide you with the answers that you need. And we can provide it rapidly as well. So the technology that we're looking at is readily deployable, it's robust and reliable. As I say, they don't require complex digest systems, they don't require gas supplies, very minimal maintenance. A lot of them, as one of my colleagues has described it, is push button get banana. And it's suitable for operation by a wide range of personnel. We can train technologists to utilise it, or geoscientists. And it's capable of generating a lot of data very quickly. To give you an example, a pXRF or an FTIR can easily get through 700 samples a day. So you can keep up with your drilling campaign. And all of these technologies are able to run off portable generators. Indeed, in many cases, you can even run them off the power supply in the back of your ute. So the FAST technologies are all about looking at all of the aspects of the exploration cycle. Primarily, we use them for exploration, but you can also use them for feasibility studies. You can also use them for MET controls and assist you in identifying sort of how you want to do your mineral processing down the line. And we can use a variety of different sample types. We can deal with cores, RC chips, or in case of some analysis, we can deal with pulps. So the PNIR technology is designed to work around core and RC samples. So that's why for the mineralogy, it's kind of semi-quantitative. The EDAX systems, that's the core scanning, they're designed primarily to work around core, but it can also be used with RC. The NIR EDAX-based systems, again, we're looking at cores and RC. The FTIR is designed to work on pulps, so we do have to pulp the sample in order to provide you with the analysis. The DetectORE system, that works on effectively RC chips and for providing the gold contents. So, we routinely apply these in mobile sample preparation units, and that allows us to have things like the grinding facilities for providing for the FTIR. It also provides a better product for the pXRF to look at, and you can also incorporate the DetectORE units because that has a sample extraction system, and you'll get better results from your PNAR Cyrus software for semi-quantitative mineral ID work, or you can send samples to our main laboratories, where we have automated pXRF, FTIR and PNIR systems. So that allows you to get through hundreds or indeed thousands of samples a day. So FTIR, samples do have to be pulverised, and you can provide yourself with a mineral log. Routinely, these are used for identifying alteration halos. In the gold market, you'd be looking at things like serpentine, clay mineral contents. Sometimes for an alteration index, you'd be looking at total feldspars over total clays. You can identify different rock types, and if you're dealing with the bauxite market, obviously you can look at things like the reactive and Weber's aluminous, your lithium contents, and it's considered to be quantitative to be semi-quantitative. We routinely, if we're looking at doing a large-scale project, would calibrate against either XRD or TIMA. And we have the quality control laboratories which have XRD and TIMA to basically do the calibration against. So a couple of typical suites here. A generic suite is really designed to cover a sort of reasonable mix of minerals. The sort of thing that you could apply for most applications, but we can also tailor the suites to make them more appropriate for specific ore body types, so various igneous body suites. I've got obviously the lithium suite you see here, bauxite suites, iron ore suites, and we can tailor a suite to pretty much whatever you want. The pXRF, they come in a few different forms. We have the self-contained benchtop or gun style. You do need to matrix match those if you want to get reasonable elemental contents, and they can screen for up to 44 different elements on a pulp, usually from the range of magnesium to uranium. If you're looking at a benchtop instrument, that can go as far up as sodium, and we report data routinely in CSV format. So this is the benchtop unit, and this is a little bit more powerful and allows you to go as far up as sodium. So if you wanted to do using elemental contents for rock typing, or you want to know things about sodium feldspars, then you'd probably have to move up to the benchtop unit. But both of these units are easily deployed in mobile sample preparation units, and certainly in the case of the previous unit, it can be utilised in a ute. So we can have a pretty high range of elements we can identify. We've recently been, as I say, expanding our suite of elements. We've been able to reduce our limits of detection, some of them down, heading towards the hundreds of ppm levels, and we are also going to be releasing shortly suites specifically associated for the rare earths, which we understand is a very commodity of interest, so that will be released shortly. So we've got exploration samples for soil fractions, we've got a standard 44 element screening, so it depends on what you want as to what sort of suite you might go for. The DetectORE, now this is using our pXRF system with a specialised leaching process. So it takes in the order of 24 hours for turnaround to give yourself a low-level gold content, and silver may be added within the next 12 months. And you can still use that same instrument to do a range of standard elemental analysis. So deliverables for the pXRFs and for the DetectORE system are same-day gold contents. Gold, as though it's actually a little bit moved on from now, it's actually 5 ppb equivalent. 40 ppb validated, 5 ppb indicative gold contents. We can get good gold contents even where you have nuggety gold. We have simple in-field preparation, and it's reportable in our LIMS system. The PNIR system, so this is near infrared. This can identify and be used on rock chips and core, and is a semi-quantitative mineralogical analysis system. And the advantages are that you get a wide range of minerals very quickly without having to grind up the sample. Large suite of minerals there, including an appreciable number of those associated with ultramafics and also altered systems. We can use these systems in field or in a portable laboratory with our rapid analysis system, so where we actually analyse the samples through bags, so that we don't have to have all the problems of separating samples out, and get a pretty decent rapid throughput direct full drilling programs. And we have a number of different approaches to this. This is the girder system, which is a little bit more complex. You put the samples into trays, and this allows you to get a far more detailed analysis, both by PNR or by pXRF. And, as I say, pretty decent range of elements that you can get, certainly enough for most VMS work. And that's from a rapid analysis system. The PNIR, we can use it effectively as a core scanning system, so you can start to look at, with your core samples, the mineral distribution, and combine that with the pXRF for the elemental distribution. And all of this data can be incorporated into our geological modelling systems. So we can use our AI-based geological models to produce models from that data, and produce predictive models on where future drilling campaigns and future mining operations can occur. And these use machine learning. So finally, I'd like to talk about the technologies we have under development. We have the LITH IQ, which is a hyperspectral analysis opportunity to develop that for the gold, bauxite and iron ore sector. So this is taking lithological information to the next level for predictive studies. The Geostat can be used, you can effectively outsource to ourselves for geological modelling and also satellite data modelling. The on-site lithium analysis, we are currently working with the PLID system, so that allows us to get lithium contents without the need for ICP or AA. So you can have a small unit getting lithium content, getting your main elements of interest, and all of the mineralogical minerals of interest for on-site lithium at the speed at which you are operating. The Ore Explore, we are looking at that for, this is for 3D elemental distribution. So we can actually, this isn't looking at the surface of the core, or the surface of RC chips. This is actually looking high energy X-ray, which actually looks at the structure within. So how your actual grains or your crystals are orientated, the elemental contents. So it's a very good way of looking at rare earth distribution or gold distribution. And finally, the LIBS system for liquid brine analysis, that's the system that we use over in South America, where we have lithium brines, and again, we're looking at a rapid way of getting lithium content without the need for an ICP. Okay, so just a little bit about the analytical technologies. The lithium content you can get from an FTIR. You can also get the mineral contents, the confirmational analysis by XRD. And this is really looking about what sort of the equivalent technologies would be. pXRF, equivalent, obviously, XRF for counter checks. For iron ore, again, you're looking at FTIR and pXRF. Rare earths, we can look at the XRF systems. Bauxite is a combination of pXRF and FTIR. For gold, we will be looking at a combination of FTIR and pXRF, and possible portable PPD. The battery metals, FTIR and pXRF, and we have various other sort of systems for more mixed assets. Okay, I'd like to open the floor up for questions, please. Any questions?
Yeah, John, just with the MMI, does the water content or the saturation of the soil impact on the bonding of those ions to the soil or the reproducibility of the sample?
Okay, so the question is, does water content impact the effectiveness of MMI? Certainly, if you have more water in a system, a higher ground water table, you'll get a more rapid flow of metal ions. But as far as actually identifying where you get your peaks at the positions, no, it doesn't. So it's still we've worked the system very effectively, for example, in Canada, where you've got obviously a lot more water, a much higher water table, and you still get very good peak identification, even though, as I say, there's more water in the system. Okay. Any more questions?
I'll ask one. You showed images of containers and things like that obviously require a fair bit of setup. Presumably some of these techniques that we use with just a few people in the field. Did you want to talk about how capable it might be for just like a real low budget sort of exploration techniques?
So the question is, do we have it for effectively for on-site drilling operations, which could be operated maybe from the back of the ute? Yeah.
Soil sampling.
Certainly, yeah. I mean, the soil sampling for the MMI can certainly be done from the back of the ute. The analysis by pXRF and PNR will certainly be done from the back of the ute. FTIR, the ute itself is portable enough to be used from the back of the ute. The issue is that you have to pulp the sample. So for that, I would probably go for a mobile sample preparation unit to give consistent results. You could utilise it with a mini mill, but it would increase the potential error because the pulp does have to be ideally 80% passing 75 microns.
More questions? All right. I guess that's it. Thank you.
Okay, well, thank you to everyone for attending today, and if you have any questions that you want to ask after the event, then please feel free to do so. Thank you.